Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. This is a video recorded for our introductory transport phenomena class based on the textbook by Welty, Rohrer, and Foster. We are looking at Chapter 2, Fluid Statics, and we are wrapping it up with looking at the section on buoyancy. So, buoyancy is best described by Archimedes' principle. The buoyancy force has a magnitude equal to the weight of the fluid displaced by the body and is always directed vertically upward. It passes through the centroid of the displaced volume. So, the buoyancy force is rho g times the volume displaced. Now, if the weight of the object is the density of the body times g times the total volume, then for an object that's going to float, the volume that is submerged compared to the total volume is going to be proportional to the density of the body compared to the density of the fluid. Okay, now this is true for objects that float. Let's look at an example and see how we can apply that. So I have a 50-gallon oil drum filled with air, and it's going to be used to help a diver raise a ship's anchor from the bottom of the ocean. The anchor weighs 400 pounds in seawater, okay, and the empty barrel weighs 50 pounds in air. How much weight will the diver be required to lift when the submerged barrel is attached to the anchor and the density of seawater is 64 pounds force per cubic foot? Now, note that the anchor weighs 400 pounds force in seawater. That says that the buoyant force of the anchor has already been taken into account. Okay, so that's kind of a little bit of a tricky detail there, but that is going to be just the weight of the anchor apparent to the diver. Okay, we've already taken out the buoyancy of that. So how will we solve this? So basically, we are looking to raise this, so we want the forces in the z direction. We want to apply enough force so that there is, the sum of the forces is 0. In this case, I have the force of the diver. I have the weight of the barrel. I have the weight of the anchor, and I have the buoyancy force of the barrel. Okay, now note the weight of the anchor is with the buoyancy force of the anchor already adapted, so I put a star on that one to remind us of that. Okay, in this case, rho g for the seawater